Welcome to our mathematics class. Today we will focus on introduction to trigonometric functions. We will take off from where we left off. We learned that trigonometry comes in very handy by bringing with him more tools and techniques to the solutioning of all types of triangles. We also learned that there's a mathematical relationship between the angles and the sides of a triangle. That relationship is based on what is called trigonometric functions. There are 6 trigonometric functions. 1, sine, abbreviated sin, which is also pronounced sine. Cosine, abbreviated cos. Tangent, cotangent, secant, and lastly cosecant. Let us focus on the sine at the moment. Given a triangle AOB, let us focus on the angle alpha. Line AB is called the opposite side of angle alpha. Line OB is called the adjacent side to angle alpha. And line OA is called the hypotenuse. Given again the same triangle AOB, let us focus now on angle beta. The line AB is called the adjacent side to angle beta. The line OB is called the opposite side to angle beta. The line OA is called the hypotenuse. Now, focusing on the sine alpha is defined as the length of the opposite side to angle alpha divided by the length of the hypotenuse side. In short, sine alpha is equals to AB over OA. And making AB the substitute formula, it is equals to OA times sine alpha. The same can be done focusing on sine beta. To say sine beta is defined as the opposite side to angle beta divided by the length of the hypotenuse side. And in short, that gives us sine beta is equals to OB over OA. And OB can be made the substitute formula, which becomes OA times sine beta. Now, let us consider the cosine function with the focus on alpha. And now, cosine alpha is defined as the length of the adjacent side to angle alpha divided by the length of the hypotenuse side. And in short, that becomes cos alpha is equals to OB over OA. And then OB being made the substitute formula, it becomes OB equals to OA times cos alpha. Still considering the cosine, but the focus being on the angle beta. Cos beta is equals to the length of the adjacent side to angle beta divided by the length of hypotenuse side. And in short, that gives us cos beta is equals to AB over OA. AB made the substitute formula, it is equals to OA times cos beta. Now, focusing again to another function, which is the tangent. And the tangent is defined as the tangent of alpha is equals to the length of opposite side to angle alpha divided by the adjacent side to angle alpha. That gives us tan alpha is equals to AB over OB. And AB made the substitute formula, it is equals to OB times tan alpha. We can do the same with the focus on angle beta, and angle beta tan beta gives us the length of the opposite side to angle beta divided by the length of the adjacent side to angle beta, and that gives us tan beta is equals to OB over AB. And then OB can be made the subject of the formula to become AB times tan beta. Now the shift now moves again to a new function, which is the cotangent, and the focus being on angle alpha. And now cot alpha, or the cotangent of alpha, is equals to the length of the adjacent side to the angle alpha divided by the length of the opposite side to the angle alpha. And that gives us, in short, cot alpha is equals to OB over OAB. And OB made the subject of the formula, it becomes AB times cot alpha. The same can be done with focusing on the angle beta. Cot beta is equals to the length of the adjacent side to angle beta divided by the length of the opposite side to angle beta, and that gives us cot beta is equals to AB over OB, which AB made the subject of the formula becomes OB times cot beta. The next function is the secant, and it is defined as sec alpha is equals to the length of the hypotenuse side divided by the length of the adjacent side to angle alpha. Sec alpha is equals to OA, which is the hypotenuse, divided by OB, which is the adjacent side. And OA can be made the subject of the formula to be equals to OB times sec alpha. Now shifting our focus while we're still on the secant to the angle beta. Sec beta is given as the length of the hypotenuse side divided by the length of the adjacent side to angle beta, and that in short becomes sec beta is equals to OA over AB, and then OA can be made the subject of the formula to become AB times sec beta. And lastly, looking at the function cosecant and focus being on angle alpha. The cosecant of alpha is equal to the length of the hypotenuse side divided by the length of the opposite side to angle alpha, and that becomes cosec alpha is equals to OA over AB. OA is equals to AB times cosec alpha. And again, looking at the cosecant, but the focus being on angle beta. The cosecant beta is defined as the length of the hypotenuse side divided by the length of the opposite side to angle beta, and that gives us cosec beta equals to OA divided by OB, and OA made the subject of the formula becomes OB times cosec beta. In summary, given this triangle, we can say sine alpha is equals to the opposite side divided by the hypotenuse, and that can be shown to be equals to AB over OA. The cosine alpha is equals to the adjacent side to angle alpha divided by the hypotenuse, which in this case is OB over OA. The tangent of alpha is defined as the opposite side to angle alpha divided by the adjacent side to angle alpha, and that gives us AB over OB. The cotangent of alpha is equal to the adjacent side of angle alpha divided by the opposite side of angle alpha is equals to OB over AB. The secant of alpha is equals to the hypotenuse side divided by the adjacent side to angle alpha, and that gives us OA over OB. The cosecant of alpha is equals to the hypotenuse side divided by the opposite side to angle alpha, which is equals to OA over OB. And the same can be done with the focus now on angle beta to say sine beta is equals to the opposite side of angle beta divided by the hypotenuse side, and that equals to OB over OA. The cosine of beta is equals to the adjacent side to angle beta divided by the hypotenuse, which is equals to AB over OA. The tangent of beta is equals to the opposite side of angle beta divided by the adjacent side to angle beta, which gives us OB over AB. The cotangent beta is equals to the adjacent side to angle beta divided by the opposite side to angle beta, which gives us AB over OB. The secant of beta is equals to the hypotenuse side divided by the adjacent side to the angle beta, and that gives us OA over OAB. The cosec beta gives us the hypotenuse over the opposite side to angle beta, which is OA over OB. And then summarizing this in short, we can remember this by using what is called soccer toe, which gives us to say the sine is opposite divided by the hypotenuse side of the given angle. The cosine is equals to the adjacent side divided by the hypotenuse, and the tangent is the opposite divided by the adjacent. Now in this case, the other remaining functions like the tangent, the cotangent, it is the inverse of the tangent, which is adjacent over opposite. The secant, it's the inverse of the hypotenuse of the cosine, which is hypotenuse over adjacent. And now finally the cosecant is the inverse of the sine, which is hypotenuse over the opposite. And this basically it's the knowledge that we need to have regarding the functions. But now let us look at the application of it thereof. Given a triangle AOB with OB being 10 units and OA being 10 units, OB being 6 units, and AB 8 units. And then we'll say sine alpha is given as the opposite side of angle alpha, which is 8, divided by the hypotenuse side, which is 10. And as a result, that becomes sine alpha is equals to 8 over 10, and it can be simplified to 4 over 5. Cos alpha is the adjacent side divided by the hypotenuse side. So the adjacent side of alpha is 6 units divided by 10, and is simplified to 3 over 5. The tangent is the opposite side of alpha over the adjacent side of alpha. The opposite side of alpha is 8 units, and the adjacent side to alpha is 6 units, which is equivalent to 4 over 3. The cotangent is the adjacent side of alpha divided by the opposite side to alpha. The adjacent side is 6 units, the opposite side is 8 units, and it's equivalent to 3 over 4. The secant of alpha is the hypotenuse side divided by the adjacent side. The hypotenuse side is 10 units, the adjacent side is 6 units, and that is equivalent to 5 over 3. The cosecant of alpha is the hypotenuse divided by the opposite side of alpha, which is equals to 8 divided by 10, which means the hypotenuse side is 10 units and the opposite side is 8 units. And that is equivalent to 5 divided by 4. And our lessons ends here. and I look forward to meeting you in the next lesson, where we'll do more applications on the on the functions of the trigonometric functions, and we will learn more what is meant by the co-functions and so on. Thank you.